Okay, so when you use Kubernetes, you may hear some terms like API gateways, Kubernetes gateways, and service matrices. But it will confusing, right? So in this session, Navendu will share how to distinguish these terms. And let's welcome to Navendu.
Yep. Hello. Can you hear me? Can you hear me? Like?
Yeah.
Okay. So thank you for having me, and I guess you already know about API gateways now because of the last session. Yeah. So probably I'll help you clear a bit more about Kubernetes gateways and service meshes and how they are different from API gateways. And I mentioned comprehensive. Comprehensive means complete, but I don't know if you can learn about this completely in 30 minutes, but let's try, right? Okay. So a little bit about me. I'm a maintainer of Apache API 6, which is an API gateway, and I worked on some CNCF projects. So this is the CNCF group, and like you all know. So I worked on some service mesh projects, and I'm also a Google Summer of Code and LFX mentor, so I try to help new contributors in open source. You can find me on Twitter or X. Yeah. So why are we confused? Is the mic working? I'm not sure. Is it working?
Use the head.
Okay. Yep. So why are we confused? So just like this slide, it is confusing what is API gateway, what is Kubernetes gateway, and what is service mesh. So let's make this slide less confusing. So the first point is all of these three technologies, they use the same keywords. So canary deployments, rate limiting, service discovery, like all of these tools does that. All of these tools use reverse proxies. So like the last speaker said, they use Nginx. So similarly, service meshes uses reverse proxies, and Kubernetes gateways also use reverse proxies. And API gateways have Kubernetes gateways, and API gateways have service meshes. Some service meshes have their own API gateways and all sort of stuff. So it's confusing. And there are a lot of articles and lot of videos from these influencers which compare service meshes and API gateways and Kubernetes gateways, and they say which one is better than the other, but that is completely wrong. So in this talk, I wanted to share what all of these are and why you should be using them or why you shouldn't be using them. So both cases, I guess. Okay, so API gateways, basically they are just reverse proxies with a lot of capabilities. That's it. It's a reverse proxy. It can serve your application, but it has a lot of features. So it sits between your client applications. So let's say mobile apps or like web apps or anything, and your backend, which is your APIs. And it accepts client requests, forwards them to the APIs, forwards them to the backend APIs, and returns the response back to the client. That's the basic function, and it does a lot of stuff on top of it, as mentioned in the previous talk. So it does observability, it does traffic control, it does authentication, security, all sort of stuff. So a reverse proxy with a lot of capabilities. So this is basically what an API gateway architecture would look like. So you have your client applications, you have your API, and the API gateway accept all traffic and then forwards it to your backend application, and it does all of these functions. So I work on Apache API 6, which is an open source API gateway hosted by the Apache Software Foundation, and there are other open source API gateways as well, like the gentleman before me mentioned, Kong. There is also a project called Glue and Tyke, but there is also proprietary stuff from the major cloud providers. So AWS has their own API gateway, which is completely proprietary, but like people still use it. So canary deployments. So we first mentioned that all the three things, API gateways, Kubernetes gateways, and service meshes can do canary deployments. So let's look into that and see what it is about. So a canary deployment is basically rolling out your software to a small subset of users first, just so that you can test it out, and then making it generally available. So initially here you have your v1.0 and you just released v2.0, but you are not sure if it is bug free, you just want to test it. So first you will use a API gateway like Apache API 6 to route most traffic to your first version and just a small amount of traffic to the second version. And gradually as you test out this new version, you can reconfigure API 6 to route all traffic to this version. So this is what a canary deployment looks like for an API gateway. So let's move on to Kubernetes gateways. So API gateways and Kubernetes gateways sound similar. The only difference is that Kubernetes gateways are API gateways which is deployed in Kubernetes. That's it. So you can use Kubernetes API to configure these API gateways. So you deploy an API gateway in Kubernetes and you use the kubectl commands, like you configure a pod or a service, and you use that to configure the API gateway. That's the only difference here. So to work with Kubernetes gateways, Kubernetes provides two APIs. The first one is the Ingress API. This is the existing API. It is part of the Kubernetes release. It is generally available. And there is this new API called the Gateway API, which aims to solve a lot of problems with the Ingress API. So these two APIs lets you configure a Kubernetes gateway within Kubernetes. Okay. So we talked about APIs, clients, and everything, right? Now we move to the Kubernetes world. Now your APIs are pods and services in a cluster. So that's the change here. So instead of your APIs being separate, it is now deployed in a Kubernetes cluster, and you have an ingress or a gateway in front of your APIs, which is sending traffic to your APIs. Does that make sense? Yeah. Okay. So you have two options, either the Ingress API or the Gateway API. The rest of the stuff remains the same. Everything is deployed in Kubernetes. So I mentioned Kubernetes gateways are just API gateways in Kubernetes. So the way it works with Apache API 6, the API gateway we talked about, is that it deploys API 6 in Kubernetes, then it adds another layer on top of it. So API 6 ingress controller is another layer on top of API 6, kind of like a wrapper on API 6 that lets it that translates Kubernetes configuration into API 6 configuration. So you are a Kubernetes user, you will use Kubernetes configuration to configure your API gateway, and the ingress controller converts it to API 6 configuration. So the rest of the stuff remains the same. It works similar to out of Kubernetes, but now you can use a kubectl command to configure the gateway. So a Kubernetes gateway now becomes an API gateway plus an ingress controller, and that is how most projects work. So like I mentioned, the ingress controller basically takes in the YAML file, the Kubernetes YAML file, which is defined using the Kubernetes Ingress API or the Gateway API, and then converts it to the API 6 configuration. Let me just show you a demo. All right. Okay, I hope you can see the JSON file here, right? Okay. So this is a canary deployment configuration of API 6 when API 6 is deployed outside a Kubernetes cluster. So it's pretty basic. You configure a route. So when requests come to this route, API 6 will route it to your backend services. So basically you have a backend service and you are sending 95% of the request to one service and 5% to another service, which is the V2 service. Pretty simple, right? Now if we move to the Kubernetes stuff, it remains the same. All of the configuration remains the same, but now you are writing a YAML file. So it's of kind ingress. So like I mentioned, ingress is generally available in Kubernetes releases. So you can use this API and yeah, and just configure the canary release here. So to configure canary release, it's a bit different with the ingress API because ingress API is pretty much limited. So you have to use custom annotations like the ones mentioned here. So you mention that you need a canary annotation, and you say you want to make it a canary release, and you want to set the weight to 5. So only route 5%. But annotations are like really messy. If you want to do more complex stuff, you end up adding a lot of annotations. So what happened was companies or like projects, they created their own CRDs. They created their own Kubernetes custom resources to overcome this. So API 6 has this CRD called API 6 route, which lets you define API 6 configuration in Kubernetes. So when you look at this configuration, it looks much similar to what we had here, right? So it is much more human readable, it is much more maintainable, and it's much more like as soon as you see it, you can figure out what is happening with this, and you don't need any custom annotations. So that's the Kubernetes CRDs. But the main problem here is that API 6 route is specific to API 6. So if you want to change to, let's say, Kong, if you want to use Kong API gateway or Nginx API, Nginx ingress, this configuration will not work. So, but with ingress, whatever its limitations, it will work with any other, it is portable. So it doesn't depend on API 6 at all, but when you come to CRDs, it adds that dependence. All right. So yes. Yeah. Okay, wait. Okay, so it adds that dependence, but now when we move to the gateway API, which is the new API that we talked about, which has the goal to like eliminate the problems faced by the ingress API. So in the ingress API, we had these annotations. We solved it using custom resources, but the gateway API tries to accommodate all of that in the Kubernetes spec itself. So instead of relying on custom CRDs, you can just define these stuff as you would for any other implementation of the gateway API. So you can use this configuration for API 6. You can use this same configuration for Kong. You can use the same configuration for Nginx. So you can basically replace your implementation, replace the tool you use, but you can have the same configuration. All right, so it looks much similar to our CRDs, and that is because a lot of these projects, they came together and they are designing this new gateway API. So they are figuring out what went wrong with the ingress API, the limitations of the ingress API, and now they are building a better API, but it is still in alpha releases. It is not available out of the box in Kubernetes. You have to manually install it, and a lot of the stuff is still experimental, but it is the future. All right. So now let's come to service meshes. So both API gateways and Kubernetes gateways had a lot of similarities, as we discovered. They work across application boundaries, so they handled north-south traffic. But service meshes do something different. They are concerned about inter-service communication, which is between each service. That is called east-west traffic. So an API gateway and Kubernetes gateway did north-south traffic, but a service mesh does east-west traffic control. So how this does traditionally is by using a sidecar proxy. So this also use proxies, and each of your API, each of your service deployed in Kubernetes has its own sidecar container. And instead of these services communicating with each other directly, and the application developer having to configure that communication himself, we will use a reverse proxy, and this set of reverse proxies is called a service mesh, and there is a service mesh control plane that does all the networking for you. So you just deploy your application, and you deploy it on top of a service mesh, and it will handle all the networking for you. So there are a lot of popular service meshes. Istio is the most popular service mesh out there. Then you also have Consul from HashiCorp and Linkerd, which is one of the best open source projects. But Istio recently joined the CNCF, and it recently graduated. So yeah, most of the service mesh users out there use Istio. But there is also a new technology called relatively old technology, but something that had its resurgence recently, called eBPF. So eBPF lets you do stuff on the kernel easily, and this has given a lot of new projects, and one of which is called Cilium. It's a new type of service mesh. So instead of each of your service having a sidecar proxy, an eBPF service mesh will have just one proxy for one node, or any other grouping. So instead of having to deploy all these reverse proxies, you just deploy one, and each of your service will talk to this service mesh through the kernel. So it makes a lot of performance improvements. It makes it it removes a lot of load from the service mesh that is seen in traditional service mesh architectures. So this is also happening right now, but we have to wait and see what the future of this would look like. So now, adding to the confusion, you can also do something like this. You can combine service mesh and gateways. So we are trying to be less confused. Now we are more confused. So you can have your service mesh for east-west traffic. So the red ones are service mesh. But you can also deploy gateways that handle north-south traffic as well. So you can get the best of both worlds. So you can use a powerful API gateway like API 6 to manage traffic, north-south traffic, and then you can use a powerful service mesh like Istio to handle your east-west traffic. So that makes the system much more efficient, but it's the question of whether you should do it, because just because you can do something doesn't mean you should do it, right? So yeah. All right, now let's look at a canary deployment in a service mesh. So instead of client load balancing clients between multiple services, in a service mesh you can do something like this. So one service can one service can split requests between two other services. So similar to what we'd seen before, like you can initially send most traffic to one service and then gradually switch it to the next service, and you can do it anywhere in your service. So when you were using an API gateway, you were limited to the application boundary, but now you can do it anywhere in your architecture. And there was this project called Service Mesh Interface, SMI. There is no E. I think I made a typo, but yeah. So it tries to make service mesh vendor agnostic. So you can define one configuration file, and the goal of the project was to like use the same configuration for multiple service meshes. But only a few projects participated in this. Few service meshes participated in this project, and it was basically a failure. But now what is happening is the Gateway API project, the Kubernetes Gateway API project, which we just saw, they are also integrating service mesh. They are also integrating service mesh support to the API, and it is done through this Gamma initiative. So you can also use the Kubernetes Gateway API to manage service meshes as well. So now you can take one API, the Gateway API, use it to manage your API gateways within Kubernetes and your service meshes. And Istio, the most popular service mesh, they plan to use the Gateway API as the default API in the future. They have already announced this, and they have a lot of documentation about this, and this makes it much easier for us users. We can just work on this Gateway API, and like the rest of the infrastructure is doesn't matter to us. And the Service Mesh initiative project, which recently failed, they also joined the Gamma initiative. So now everything is coming together. And the Gateway API for Service Mesh also supports canary deployments. So people will keep saying that. So what should you use? That's the question, right? We talked about all of this stuff. We talked about how they are different. We talked about how they are similar. We talked about how they can work together. So what should you use? And the correct answer is it depends. But it depends on you. It depends on who you are. It depends on what you are trying to do. So most of the times when you're working on a small application, you won't need an API gateway, you won't need a service mesh, you won't need nothing. You just need to deploy it in some server, some bare metal server running an Apache proxy, and then just basically, send request to the server. But when you are trying to like when you want more capabilities within your service, like when you want more networking capabilities, when you want more observability within your service, when you want more fine-grained traffic control within your services, then it might make sense for you to use a service mesh. But otherwise, if you are deploying services within a Kubernetes cluster and you just want some basic traffic control, you just want to do some distributed tracing, you want to add authentication to your services, you want to add basic traffic control in front of your services, that's when you use the Gateway API or the Ingress API with an Ingress controller implementation. And if you are using, if you are not using Kubernetes, if you are just deploying it outside, if you are not using any clusters, you can use an API gateway and it will still work the same. You don't have to use Kubernetes to get all of these routing features, all of these observability features. You can use it without Kubernetes as well. So the key here was to like introduce you to these topics. I assume that you will have a lot of questions. I assume that you will have a lot of stuff that might have went over your head. Yeah, but the key idea was to like introduce all of these. I think I was able to do that, but there is also stuff you can read afterwards. So there is this article I wrote a while ago, which which is basically the article version of this talk, but it goes into more details about what these are, and like it also goes into some configuration aspects. So it is a bit more in detail, and there is also a simplified Chinese translation for the article, so you can also try that. And if you have any questions now, feel free to ask them. I will be happy to answer. And you can scan this QR code to access the article. So yeah, thank you, and I open the floor for questions. Yeah.
So, anyone have any questions? Okay.
I have a question about the STL migration. So I want to know, as you mentioned that the STL legislation will support KV API as the default API.
Yeah.
So if I'm a current user, if I want to upgrade my STL, should I do anything manually, or the STL will migrate everything for me? Because I know for the KV API, they have a new custom resource Kubernetes. So should I modify any file by myself, or anything will be done by the STL?
Yeah, like from what I understand from Istio's statement, they will use it as the gateway API as the default API, but they will still support virtual services, Istio virtual service. So if you are using Istio virtual service, it will still work. You won't need to migrate to gateway API, but like it might make sense to migrate if you are planning to like switch Istio with some other service mesh maybe. So if you use the gateway API, you don't have to worry about changing configuration in the future. Yeah.
Any questions?
Yeah.
Go ahead.
I have some questions about here. And,
Okay.
because service mesh is based on the kernel side, so what's the situation between the cross nodes?
Yeah. So from the service mesh projects that use eBPF, the way it works is one node will have a reverse proxy. So instead of each service, each pod having a reverse proxy, one node will have a reverse proxy, and inter-node communications will be through these reverse proxies, similar to how traditional service meshes work. But within a node that shares the kernel, it will communicate through the kernel. So that is the design, I guess, right now. Yeah.
So it's based on the lower side to use the kernel communication.
Sorry.
So it's based on the kernel side to make the network connection.
Yeah. So when a service talks to another service, instead of going through the reverse proxy, it goes through the kernel. So a lot of request latency is avoided. A lot of like other bottlenecks that comes with using a proxy is avoided. So it's much faster. It lets you do more stuff like within the kernel itself. So I mean like things like better observability, like better traffic control, all sort of stuff. So yeah, that's the advantage you get. But yeah, like for the first question, like if you are using inter-node communication, then you might need to use a reverse proxy. Yeah. Any other questions?
I think we can open one more simple question.
Yeah.
Okay, go ahead.
I got one problem is that when we implement eBPF in our kernel as reverse proxy,
Okay.
how can we guarantee to monitor our metrics?
You mean metrics, like?
Yeah, like in current SDO service deployment, we can explore our metrics by using an input proxy, right?
Yeah.
How is it possible to monitor when we implement
eBPF. Oh yeah.
or COSCUP?
Yes, there are a lot of projects that does this observability stuff with eBPF. From what I understand, like it is more granular. It is much better than what solutions we have. So traditionally, when we look into Kubernetes, we talk about observability. We say things like Prometheus, that sort of stuff, right? But the eBPF based observability solutions are much more granular and much more better. So it lets you do more stuff. Yeah.
Thank you. I think
Yeah.
Sandra already time. So let's thank you for Navendu. And our session will start after 10 minutes. Thank
Oh.
you, everyone.